This lesson is about linear versus nonlinear functions. A linear function makes a straight line when you graph it. So if you want to check and see if an equation represents a linear function, you can just graph that equation. So if we have the equation f of x equals 2x minus 4, we would graph this using the slope and the y-intercept on our x and y-axis. Remember, the number without the x is the y-intercept, where we start on the y-axis. And the number with the x is the slope, which is always over 1 if it's not already a fraction. So we can rise 2 and run 1, or go up 2 over 1 to get our next point, and then draw the line through those two. Since this is a straight line, that equation represents a linear function. Not all graphs are straight lines. Also remember that f of x could also be y. So you could think of that equation as y equals 2x minus 4. This is just a new notation that we only use for functions. If we want to determine if an equation is linear, the best way is to graph that. Now, it could be a linear function, a nonlinear function, or not a function at all. So we're going to check each of these 5 equations by graphing them to see which situation it is. If you're on a computer, there's a website called desmos.com that has a graphing calculator that'll help us with this problem. If you type in each equation, we can graph this and see what it looks like. The top equation, equation A, I've graphed in red. You can see here on the graph that it's a straight line, so that would be a linear function. The second equation, equation B, I've graphed in blue. It's a straight up and down vertical line. Now that might seem like a linear function, except that it doesn't pass the vertical line test. This is not a function at all, because if you draw a straight up and down line through that blue function, it's not going to pass the test. It's going to touch everywhere at the same time. So remember, a vertical line is not a function, even if it is linear. The third equation I graphed in green, that one is this curvy line up through the center. This one, since it curves, is not linear, but it is a function. It passes the vertical line test. If I run a straight up and down line through that green graph, it's not going to touch more than once at a time. The fourth equation is the orange one, which makes a circle. The circle is not a function. If I draw a straight up and down line through that, it would touch the top and the bottom at the same time. And the last equation I graphed in dark purple. The dark purple has 2 parts. The left side curves downwards and the right side curves also downwards, but from the top. Since these ones don't overlap, they are a function, but since they curve, they're not linear. Remember, if it's linear, it makes a straight line, no curves. You can use the Desmos website, desmos.com, to graph these as well, if you'd like to graph them quickly just to be able to tell if they're linear, not linear, or if they're not a function at all. For the next example, we're going to graph simple linear functions. If we already know it's linear, we know we can graph it with a straight line. So we're going to look at a couple situations. For the first situation, we have a hot air balloon rising in the air. So if we graph the height of that air balloon over time, it's going to be a line that's increasing or going upwards as that air balloon rises into the air. The second situation is a car that's slowing down. So if we graph the speed over time, since it's slowing down, we would have a line going downwards as it's decreasing the speed. The third situation is if the temperature in a room is staying the same. Now, if it's staying the same, it can't go up or down. The only option then, if we're going to graph the temperature over time, is to have a straight horizontal line, which means it has a constant temperature.